please hit the subscribe and like button already if you're enjoying this.
So by 5th week, they will have reached there and they will invade by the 6th week. If the primordial germ cells fail to reach the gonadal ridges, the gonads do not develop. Now, I explained to you that yesterday that the primordial germ cells will differentiate to form the oogonia in females. And when you form the oogonia, I explained that females are not born with the oogonia because the oogonia will differentiate to form what we call the primary oocyte, which will start meiosis 1 that will be stopped at the prophase phase. Males, we are born with our spermatogonia. The primordial germ cell will differentiate to form what we call the spermatogonia. So we are born with our spermatogonia. So the body knows the spermatogonia. But it's when you reach puberty that the spermatogonia will begin to divide to form the spermatis. So if it's from the sperms or the spermatocytes, the body doesn't know it because that's the first time it is seeing it. So it means that if the body sees it as a non-safe, the immune system will destroy it. So there is this blood-testis barrier. You see that what you see here are the spermatogonia. Those are the ones that are here, the one that the body knows. So the blood-testis barrier ensures that the immune cells do not reach here to destroy these. So that's one important function of the blood-testis barrier. And the Sertoli to Sertoli junctional complex is where the blood-testis barrier is formed. Now, let's look at the process. Spermatogenesis. Spermatogenesis is a process by which the hybrid spermatozoa develop from spermatogonia in the seminiferous tubules of the testis. They begin shortly after puberty under the influence of the follicle-stimulating hormone and testosterone, and continues throughout life. So by 12 to 14 years, when you have attained puberty, spermatogenesis will continue till you die. Of course, the amount of sperm that you produce will decline as you age. The duration is reported to be about 74 days, and about 200 to 300 million sperms are produced per day. There are 3 phases. The 3 phases are the proliferative phase. You see, remember we have spermatogonia. So there's going to be a proliferative space or the spermatogonia space. Then the next phase is when meiosis will take place. And the last stage is what we call spermiogenesis. So those are the 3 phases. So we are going to look at the individual phases. I'm not going to read this. I'm going to look at it here. I think I've already said something about primordial germ cells. So once again, we have primordial germ cells, which we know will migrate to the yolk sac. They move from the yolk sac to the gonadal ridge. In case of spermatogenesis, the testis. We say that to remain dormant to reach puberty. When you reach puberty, the hypothalamus, when you reach puberty, the hypothalamus release a hormone that we call the gonadotropin releasing hormone that will move to the anterior pituitary gland. Know that the pituitary gland is connected to the hypothalamus by the pituitary stalk, or what we call the infundibulum. And the pituitary gland, there's an anterior pituitary gland and there's a posterior pituitary gland. So the hypothalamus release the gonadotropin releasing hormone that will cause the cell, the gonadotropes, to release a hormone that we call FSH and LH. FSH means follicle stimulating hormone, and LH means luteinizing hormone. I explained to you that the luteinizing hormone will act on a Leydig cell to secrete testosterone. And also explain that the FSH together with testosterone is responsible for this process that we call spermatogenesis. So remember, FSH, spermatogenesis, LH, testosterone production by the Leydig cells. So here, what I'm saying is that when a spermatogonia is formed, you are going to differentiate. So you're going to proliferate, divide to produce several types. So you're going to produce several type A, dark type A spermatogonia. So here you have dark type A spermatogonium, dark type A spermatogonium, means that they are going to produce several spermatogonia. And here, due to the staining, scientists have found out that the spermatogonia that the daughter cells, they are different. There's one that we call type A, dark. We also have type A, pale, and we also have type B. So there's type A, dark spermatogonia, there's type A, pale spermatogonia, and there's type B, spermatogonia. So here you have several of type A, dark spermatogonia that we produce. Some of the type A, dark spermatogonia will also proliferate to form type A, pale spermatogonia. And once again, you are also going to get some that will be type A, dark spermatogonia. The type A, pale spermatogonia will undergo mitosis to produce more of its kind, and some of them will differentiate to form what we call type B spermatogonia. Now, what you need to understand is this. Let's assume that the male will have 500 spermatogonia. If all the 500 spermatogonia were to differentiate to form the sperms, it means that once the number is finished, that is going to be the end. But it doesn't happen that way. At any point in time, there is a reserve. There's a reserve of the type A. There's always reserve type A. So that's why you have, you see, this one here is becoming type A pale and type A dark. At that point in time, you still have a reserve of what? Then type A dark was spermatogonia. So it is when it move from type A pale and become type B spermatogonia, then that we can say that the process is what? It's starting. So the type B spermatogonia will then differentiate to form what we call the primary spermatocytes. become the primary spermatocytes. Then, so this process is what we refer to as the spermatogonia phase. So the spermatogonia phase, there's a repeated mitotic division that converts the spermatogonia to primary spermatocytes. Once the primary spermatocytes is formed, then we move to the meiotic phase. So there will be first meiotic division and second meiotic division. So the first meiotic division, the primary spermatocytes will become secondary spermatocytes. In the second meiotic division, the secondary spermatocytes will become the spermatids. The four spermatids will have reproduced. The spermatids that are produced, they are spherical in nature. And we know that the sperm is shaped like a tadpole. So there's a morphological change that goes on that transforms the spermatocyte, the spherical spermatids, to the tadpole-shaped sperms that we know. And that process is what we call spermiogenesis. Spermiogenesis. The spermiogenesis, look at this. So this is what is formed at the end of the second meiotic division. Spermatids, which are spherical. But this is how a mature sperm looks like. A head, a middle piece, a principal tail, and an end tail. Within the head, you find the nucleus. And most of the space is occupied by what we call acrosome. Acrosome contains enzymes that is essential for the oocyte penetration. So this transformation from a spherical to this tadpole shape is what we call spermiogenesis. So you see here the process, some of the excess cytoplasm will phagocytose by the Sertoli cells. And that was one of the functions of the Sertoli cells that we mentioned. In the spermiogenesis, the sperm develop a middle piece. They form a head, acrosome, and even a tail. So that process is what we call spermiogenesis. Newly released sperms are non-motor and are carried from the seminal tubules in a fluid secreted by Sertoli cells. So that is what I explained by the process that we call spermiation. So that fluid will help to release the spermatids that are attached to the Sertoli cells into the lumen. Once again, remember, the sperms are non-motor at that point in time. They acquire motility as they pass through the epididymis. So that's what after spermatogenesis, the sperms are released from the supporting Sertoli cells into the lumen of the seminal tubules. The process that we call spermiation. Newly ejaculated sperms are incapable of fertilization until they undergo the process that we call capacitation. The capacity to fertilize the egg. When the sperms are released, they must undergo a process that we call capacitation. And capacitation occurs in the female reproductive tract. So it means that even in IVF, when sperms will be, the man who ejaculates or masturbates for them to get the sperms, they can't just fertilize the egg because the sperm have to pass through the female reproductive system and undergo a process that we call capacitation. So basically, some glycoproteins and other molecules are removed from the sperm plasma membrane. Because fertilization is occurring outside, it means that the embryologist will have to do the capacitation outside, remove those glycoproteins before the sperm will be capable of fertilizing an egg. So here, once again, you have what we're talking about, the spermatogonia phase, where you have the spermatogonia undergoing several mitotic division. Type A dark, and some of the type A dark will serve as a reserve, and others will become type A pale, and some of them A pale will differentiate to become type B spermatogonia, and the type A to become what? The primary spermatocytes. When they become primary spermatocyte, then the second phase will begin, what we call the meiotic phase. The first meiotic division, they will become secondary spermatocytes. And the second meiotic division, they become spermatids. The spermatids will then undergo a transformation that we call spermiogenesis to become the sperms. Then the sperms to become what? The sperms. Now, another thing that you need to understand is this. If you look at these spermatids, you realize that there is a connection. You see, when the cells are dividing, you know, what we call cytokinesis, where the cytoplasm will divide, there is still a cytoplasmic bridge. So the idea is that it ensures that there is synchronicity of the end process. So you can take, let's say, group B1. Maybe the group leader is the one that has become is dividing to give rise to other members of that group. They are saying that they are not going to become individuals. There's going to be cytokinesis will be incomplete. So there will still be cytoplasmic bridges that connect them that will ensure synchronous productions of the sperms. So the mature sperm that we talk about have a head, a middle piece, the tail, the principal tail, and the end tail. The nucleus will contain the haploid part. The midpiece will contain what? A spiral mitochondria. The mitochondria is the one that will provide the energy needed for the sperm to swim. Because you have to swim. You have to swim. You have to swim. And I also said something about the acrosome, which we'll learn later when we are looking at the process that we call fertilization. Now, briefly, when it comes to the hormonal system, sorry for this one, I should have cleaned this. I explained that the hypothalamus is the one that releases the hormone of God, the gonadotropic releasing hormones, because it's going to act on some cells in the anterior pituitary gland that we call the gonadotropes. They release follicle stimulating hormone and luteinizing hormone. The luteinizing hormone stimulates testosterone secretion by the interstitial cells of Leydig. Now, we also explain that testosterone will have to be concentrated within the seminiferous tubules so that the entire process of spermiogenesis can go on. Therefore, we said here, and you can see from here, The follicle stimulating hormone will act on the Sertoli cells to secrete what we call the androgen binding proteins that will bind testosterone and maintain testosterone concentration within the seminiferous tubules. Now, some of the testosterone in the external genitalia, there's an enzyme called 5-alpha redundase that will convert the testosterone to an active form that we call dihydrotestosterone. Please, this DHT is very, very important. This is what is responsible for the development of the male external genitalia. Development of the male external genitalia. So differentiation of penis, scrotum, prostate, male hair pattern. Okay. Now, when there is absence of DHT, it results in the development of female external genitalia. So when the sperm and the egg they meet, if it XX is a female, if the XY is a male, but that one is what we call genetic sex. Hormones are important in the development of the external genitalia. And the hormone that is responsible for the development of the male external genitalia is the dihydrotestosterone, conversion of testosterone to its active form. So once you don't have that conversion taking place, and you like the DHT, it means that you're going to develop what? Female external genitalia. Remember, the male and female structure developmentally, they are homologous. So instead of becoming a penis in the presence of DHT, you're not going to form a penis, it's going to form a clitoris. So you can have someone who is genetically is a male, and then the external genitalia is what? Is a female because of the absence of what? DHT. Probably because the person lacks the enzyme that will do the conversion. Or the person has the DHT, all right, but the external genitalia is insensitive to the hormone. Okay, so that is what is seen here. Now, because you've done something about muscle tissues, I also want you to know that testosterone is very important in protein synthesis. Because, so you see that those people who lift heavy metals, they tend to take synthetic testosterone. Because once they take it, it's going to increase protein synthesis, so that they can develop more of the bleed contract proteins, the myosin and actins, so that they can develop bigger their muscles can hypertrophy. Now, of course, if you look at here, there's also a negative feedback. The Sertoli cells, apart from producing the androgen binding hormones, also produce a hormone called inhibin. Inhibin decreases release of FSH. Let's say the process testosterone spermatogenesis is going on nicely. So at that point in time, inhibin will be produced to decrease the release of FSH. So you have this negative loop. In the same way, you have this negative loop where testosterone level is too much. It will cause the decrease in the release of gonadotropic releasing hormones. So you have this negative feedback. So please remember, LH is responsible for what? Will act on the interstitial cells to produce testosterone. FSH will act on the spermatogenesis cells, and together with testosterone are responsible for what? spermatogenesis. And once again, Sertoli cells will release inhibin, which will decrease release of FSH. And I also explain to you that the Sertoli cell will produce another important hormone that we call anti-Mullerian hormone, or the Mullerian inhibiting substance. Please look at this.
Let's the skeleton.
Look at this duct here. We call this one the paramesonephric ducts. And we call this one the mesonephric ducts. Okay. The paramesonephric ducts is also called the Mullerian ducts. So if you are saying there is something that we call anti-Mullerian hormone, what do you think that what will mean? The paramesonephric ducts is what we call the Mullerian ducts. This paramesonephric duct or Mullerian ducts is the one that will develop to form, this one will develop to form the uterine tube and the uterus. The paramesonephric ducts or the Mullerian ducts is what will become, this one here will become the uterine tube. This one here will become the uterus and the upper parts of the vagina. So in order to ensure that the paramesonephric duct or the Mullerian duct does not grow to form the female internal genitalia, the Sertoli cell secretes the anti-Mullerian hormone that will suppress the development of the female internal genitalia. So, in the presence of the anti-Mullerian hormone and testosterone, is going to act on another duct, the mesonephric duct. And that is what is going to develop from the seminal vesicle, the vas deferens, the epididymis, the efferent ductus, and the ejaculatory duct. So, I mentioned three important hormones secreted by the Sertoli cells. The anti-Mullerian hormone, and I explain what it does. It's going to suppress the Mullerian ducts or the paramesonephric duct from becoming female internal genitalia. Then I mentioned about the androgen binding proteins that will bind to testosterone and show that there's testosterone concentration in the seminiferous tubules is okay for spermatogenesis to continue. Then I mentioned that they also produce what inhibin that will act on the anterior pituitary gland to suppress the release of what? FSH. So please, that is the whole thing about spermatogenesis. If you have a question, you can ask a question.
Like they will copy from internet.
So I believe the one who said, please LH act on. So I've already explained what LH will act on. The LH will act on the lady cells. The lady cells, which are located in between the seminiferous tubules to produce testosterone.
When is physiology?
Any question again? Any question?
First class about you die.
So if you look at this particular here, this side here, in the basement membrane, you see the Spermatogoneas. Superconia are closer to the basement heart membrane, or what we call the basal heart lamina. And I said that this is the one that the body knows. Huh? So, but then there's a barrier, acetylcholine cell junction, blood Texas barrier.
I will send the link.
So, it means that this type B will have to squeeze its way. The type B will differentiate to form what? The primary what? Spermatocytes. So, you must be able to squeeze it way through here to be able to get to this side. To get to that side. Either you raise your hands or write a question. You're talking about slide. Okay, so if you don't have, I haven't seen any hands up. Haven't seen any hands up. If you raise your hands, if you tap at something, I'll answer.
You're killing me. Glycolysis, bypass, yes, now. She's making me feel insecure about my.
In terms of the penis, I don't actually get the question very well, but for your information, you know, the way we wear our boxers, short and stuffs, some of them are very, very tight. Some of them are very, very tight. So some people, when their penis becomes erect, you see that it will pointing to what? Different directions. So
9 to 10.
you may.
Hey, 9 to 1. Hey, 9 to 1. I'm 9 to 1, 9 a.m. to 1 o'clock there.
That may be the case.
I think it's not for us.
Because what is actually making the penis stiff is because of the blood that's rushing into it.
I'll get subscribers.
The blood rushing into it, that is what will make the penis stiff. When arterial blood rushes into it, the vascular line spaces. Then it's going to, when it stretches, it's going to compress on the venous blood so that it's going to prevent venous drainage. Of course, unless, of course, the person also have a problem with the ischio-cavernosus muscles, because I explained the ischio-cavernosus muscles surround the crus or the crura of the penis, and it's very important in stabilizing the erection. Now, let me show you this slide. Now, under normal circumstance, this is the glans penis, and this is where under normal circumstance you should have the external urethral meatus. But you can have a situation where the external urethral meatus is at the ventral part of the penis. This is what we call hypospadias. You can also have a situation where it's on the dorsal parts, what we call epispadias. So those are developmental anomalies that can happen.
What sort of age is that? He's done it. Still they talk.
Okay. Now, let me just say something very important also here.
Yeah.
Because the entire process of spermatogenesis
I need to get a lot of subscribers.
Takes pretty long, about 3 months. It means that you have a low sperm count, and you are taking medication to actually increase the sperm count. You can't take it within a month. and you have to take it for about 3 months before you can see what any effect, because the process takes a longer period. So you can't just take it within a month and expect miracles to happen. You have to take it at least for 3 months before you can see changes in the sperm count. So if you don't have any question for me, then we are going to call it a day. Thank you very much. I'll give the slide to you tomorrow when I have done the Oogenesis. So tomorrow, God willing, we'll start Oogenesis, the development of the secondary oocyte. Thank you very much. Now, you're saying, is it not about the level of blood flow of penis in the blood? Now, you know that if the penis doesn't become stiff, there is no erection. You see, erection must be sustained. Erection must be sustained. If you erect and then it becomes flaccid, then that one is not good enough. That's impotence. It's not good enough because it must be erected in order to enter the word vagina. It must be erected in order to what? Ejaculate. So if we are talking about the penis pointing to different directions, in fact, if less blood has flowed, then of course it will be very difficult for it to be able to stand what? Straight. The way it didn't start from straight. So I'm not sure it has to do with the blood. The blood, because if less blood flows, then it means that it's not going to even become erect. You know, because it's supposed to stand erect instead. Okay, thank you. This one is, please, our discussion on the male reproductive system. That one was an overview. What we have done today is not an overview. You'll not do it again. So if you don't know, you'll not do it again. You'll not do it again. You'll not do it again. You have a class, so I'm going to end this one. I'm going to end this one. Then if you have any questions, I can address those questions tomorrow. Thank you very much, and have a beautiful day. Bye-bye.
Recording.
Okay, sure.
Please hit the subscribe and like button already if you're enjoying this.